Hello everyone. This is the Solar Energy Application course in South Tehran branch of Islamic Azad University for international students. This is part 2 of photovoltaics. Actually, this is a continuation of our previous session about solar cells and modules. You may have a look at the link shown below to find or view the previous presentation. First, let's have a short review on what we discussed last week about the photovoltaic. If you remember, we said that solar PV system is comprised of solar module plus BOS or balance of system. Solar module is actually the heart of the system and the main part of the system. Its components, as you can see here, is a frame generally made from aluminium. There are also some modules which have no frame or frameless modules, but in general they have a frame. Then there's a tempered glass at the top. There are two EVA layers or encapsulant, which are transparent layers covering the solar cells, and then there's a back sheet at the back, and finally the junction box where the wires are coming out. We discussed about different types of modules and showed that the two main types of modules in the markets are thin film and silicon cells. Silicon cells by themselves can be classified into mono and polysilicon, or mono and multicrystalline, and thin film. You can see here all the three types, and we discussed how to distinguish between them whenever you saw one of them. We discussed about the efficiency, the meaning of cell efficiency and its comparison with module efficiency, and compared the efficiency of crystalline silicon cells, either poly or mono, with the thin films and with the new concepts. Also, I introduced a website, NREL, where generally the best research cell efficiencies are shown. You may refer to the website to be update about the most recent progress in the PV industry. Also, we told that there are other designs of the solar modules, among them bifacial solar modules, which there is no backsheet actually in the backside, and they can receive sunlight from the ground reflection. There are concentrated photovoltaics, where the sunlight is concentrated in some way into a small area where the solar cell is placed. And there are photovoltaic thermal combined collectors, where both electricity and heat is produced. We discussed about the IV curve, module IV curve. You saw that there's a curve like the one shown here below, with the vertical axis, which is current, and the horizontal axis, which is voltage. And the curve is something like this. In order to find the points in the curve, for example, to find this point, the intersection of the curve with the horizontal axis, which is named open circuit. Generally the circuit is open like this, and the voltmeter here can measure a voltage which is the maximum voltage, named open circuit voltage, while the current is 0, as you can see, because there is no current is flowing in the circuit. To find the intersection of the curve with the vertical axis or current axis, the two sides of the panel are short-circuited, and in this case the current you read here is the maximum current, which is named short-circuit current of the module, and as you short connected the both sides, then there is no voltage difference here, because the internal resistance of the ammeter is actually 0 or nearly 0. So this will be the next point, and by varying the resistance between infinity and 0, you can find other points of the curve and draw the curve, which is something like this. You may remember that there are 5 actually important parameters for each solar module or solar cell. These are the short circuit current, the open circuit voltage, the voltage at maximum power, the current at maximum power. And what is the maximum power? The maximum power is the peak point of the curve, of the power curve, and then this point is the maximum power point in the on the IV curve, and this is the maximum power which the module can produce at this voltage and this current. Generally, these 5 parameters are written in label, on a label which is attached to the back side of the panel, or and in the catalog, the data sheet of the panel. You may remember that these are all at the STC condition. What is STC condition or standard condition? It's a condition of radiation 1000 watts per square meter, an air mass of 1.5, and at cell temperature of 25 degrees C. So the data which are shown on the back side of panel and in the data sheet are at STC. This was a catalog or data sheet of a half-cell monocrystalline module, and you saw that there are generally, at least the 2 sides, generally some explanation here on the front cover, and in the back side you can see a table with some details. You may refer to the